What if the universe has been catfishing us this whole time? Well, the Webb telescope just called it out, and now space has some serious explaining to do. Scientists are officially baffled. Thanks to the Webb telescope's ultra-deep, high-def galactic selfies, we're seeing things that make even seasoned astrophysicists do a double take. Galaxies are popping up where they shouldn't be. Cosmic timelines are bending like pretzels. And theories we clung to for decades, like dark matter, dark energy, and the sacred story of the Big Bang's microwave afterglow, are suddenly looking wobbly. In short, we might need to rewrite the universe's autobiography. Rewriting the universe's autobiography, Andre Kudso from Lawrence Berkeley National Lab summed it up perfectly. We thought we were just taking notes. Turns out the universe is improvising, and it's a lot messier than we expected. Oh, and cosmic gravity. One more thing before we blast off. Gravity, the force that keeps your feet on the ground and your coffee cup falling instead of floating? Yeah, it's apparently not playing by the rules anymore. Let's break it all down. Laugh through the cosmic confusion, and maybe, just maybe, figure out what in the multiverse is going on. Let's talk about gravity. And no, not the kind that makes you trip over your own feet in public. We're talking cosmic gravity, the invisible leash that keeps planets, stars, and galaxies from going completely off the rails. Take the sun, for example. Its gravitational grip on Mercury is strong, like a clingy ex who won't let go. But when it comes to Pluto, way out in the solar system's frozen suburbs, the sun's pull is more like a lazy hug. It's barely hanging on. That's how gravity is supposed to work. The farther you are, the weaker the pull. Simple, right? Well, the universe decided to throw a wrench in that idea. In the groovy 1970s, astronomer Vera Rubin noticed something suspicious while studying how stars move inside galaxies. What is dark matter? Imagine checking out a merry-go-round and realizing that the horses on the edge are spinning just as fast as the ones near the center. That's weird, right? In theory, those edge stars should be flinging themselves into deep space like cosmic frisbees because gravity out there is supposed to be weaker. But nope, they just kept spinning around like they'd had a double espresso. There had to be something, some hidden force keeping those stars in check, something invisible, mysterious, and stubbornly uncooperative with telescopes. So, they gave it a name that sounds straight out of a sci-fi thriller, dark matter. It doesn't glow, it doesn't reflect light, and it doesn't pay rent. But it might just be holding the entire universe together like duct tape on a collapsing bookshelf. So, yeah, it turns out the cosmos has more secrets than your neighbor's Wi-Fi password. And dark matter? It's probably the biggest one of them all. So, here's a cosmic tea. Dark matter is like that mysterious neighbor who keeps their blinds shut 24/7. No one knows exactly what it is, what it's made of, or what it wants from us, but we're pretty sure it's been running the universe's backstage operation for billions of years. Scientists believe this invisible force helped glue the universe together after the Big Bang. According to the standard model of cosmology, once regular matter came into existence, dark matter stepped in like a cosmic construction manager, pulling stuff together with its gravity and building the first stars, galaxies, and those sprawling galactic highways we now call the cosmic web. Even the tiny temperature bumps in the cosmic microwave background, the universe's baby photo, show signs of dark matter flexing its muscles. So far, this mysterious ingredient has been the perfect explanation for how everything got built, until now. What has the Webb telescope been seeing out there? Frankly, it's blowing our scientific minds. It's finding galaxies way farther and way earlier than anyone thought possible. Like, we need to rewrite our textbooks early. We're spotting galaxies so far away they existed when the universe was barely 200 million years old, basically a cosmic toddler. One confirmed galaxy, charmingly nicknamed Mom Z14, showed up when the universe was just 280 million years old. And some candidates might be even older, if confirmed. That's like finding a full-grown tree in a nursery. It just shouldn't be there yet. And here's the kicker. These baby galaxies, they're not small. They're not messy. They're not acting like cosmic infants at all. Some are organized, mature, and full of older stars. One absolute show-off named J0107A is around 10 times bigger than the Milky Way, and it existed when the universe was still drooling and learning to walk. Dark matter, these early universe galaxies are making dark matter look a little suspicious. If dark matter was supposed to be the scaffold that held everything up while galaxies formed slowly over billions of years, then why are these massive mature galaxies already out there barely a couple 100 million years after the Big Bang? So now scientists are wondering, have we misunderstood dark matter all along? Or is it possible it doesn't even exist? These new discoveries, yeah, they're the kind that keep cosmologists up at night, staring into the abyss and rethinking their life choices. For decades, we've treated dark matter like the unsung hero of the universe, the invisible scaffolding holding galaxies together, guiding their growth from cosmic toddlers into the majestic spiral arms we see today. But suddenly, the Webb telescope has rolled in like a cosmic whistleblower, showing us galaxies that are simply too big and too well-developed to have followed the rules. So now we're stuck with two possibilities, and neither is comforting. Either we're missing something huge about how dark matter actually works, or this mysterious substance we've been leaning on all these years isn't what we thought it was at all. Maybe it's playing a different game and forgot to tell us the rules. Those weird ancient galaxies, they're just the opening act. The Webb telescope has also uncovered some eyebrow-raising behavior on a much grander scale across the massive cosmic structures that stretch like spiderwebs through the universe. We're talking galaxy clusters, superclusters, and filaments so large they make our Milky Way look like a grain of sand. And the dark matter theory, it's once again raising more questions than answers. Enter the S8 tension, the universe's version of a glitch in the matrix. S8 is basically a number that tells us how clumpy matter is in the cosmos, particularly across the largest cosmic scales. It's supposed to be the key to understanding how everything from galaxies to massive clusters has spread out over time. Now, here's the kicker. When scientists measure the early universe using data from the cosmic microwave background, they calculate a nice tidy S8 value that fits perfectly with our current cosmological model. But when they turn their telescopes to today's universe and measure how galaxies are actually spread out, they get a lower S8, like significantly lower. Cue the dramatic music. It's as if the universe told us one thing at the beginning of time, and is now giving us a completely different story. Either something's off with our understanding of the early universe, or the universe is just trolling us. Either way, the S8 tension is one of the biggest unsolved mysteries in modern cosmology. And thanks to the Webb telescope, it just got harder to ignore. So, buckle up because this cosmic mystery train has no brakes. You might think a small difference in measurements isn't a big deal, but in the world of astrophysics, small can mean the entire universe is lying to your face. This weird little discrepancy, it's consistent, statistically significant, and way too stubborn to be chalked up to a simple mistake. And it's not just dark matter acting suspiciously. Nope. The Webb telescope is now looking sideways at dark energy, too, that elusive force we believe is blowing up the universe like a cosmic balloon. Scientists are finding that how fast the universe is expanding depends on how you measure it. When we peek into the ancient past using the cosmic microwave background, we get one value for the Hubble constant. But when we measure the nearby universe with supernovae, boom, we get a completely different number. This galactic disagreement has a name, the Hubble tension. And trust me, it's not just an awkward family argument. It's a full-blown cosmological crisis. But wait, some astronomers now think that dark energy might not even be constant. That's right. The one thing we thought was unchanging might actually be evolving over time like a moody teenager. Suddenly, our whole understanding of the universe's expansion is wobbling like a Jenga tower at a toddler's birthday party. And just when you thought it couldn't get weirder, remember the CMB? That faint all-encompassing glow we call the afterglow of the Big Bang, the holy grail of cosmological evidence? Yeah, that might not be what we thought it was either. A new study is dropping jaws all over the astrophysics community. Researchers are now saying, what if the CMB isn't the echo of the universe's birth cry, but just a collective radiation from a bunch of early galaxies packed together like sardines? Imagine it. Countless hot young stars in the first galaxies burning bright, throwing out radiation left and right. Over billions of years, that radiation gets stretched or redshifted by the expanding universe until it looks exactly like the CMB we've been measuring and obsessing over since the 60s. According to the research, these early galaxies could be responsible for about 1.4% of the CMB's total energy. And sure, that might sound like pocket change in universal terms, but it's enough to mess with our readings. Enough to make scientists raise an eyebrow and say, wait a minute. And that's just a conservative estimate. Add in more early galaxies, and that percentage could rise significantly. If these galaxies are contributing a major portion, or wild idea, or of the radiation we thought came from the Big Bang, then the entire Big Bang narrative might need a rewrite. If all these new discoveries hold up, we're not just tweaking a few cosmology textbooks. We're talking full-scale rewrite. From the age of the universe to how galaxies formed, even the very physics we thought ruled the early cosmos, everything suddenly looking suspicious. Dark matter questioned, dark energy unsettled, the Big Bang wobbling on its cosmic pedestal. Even the beloved cosmic microwave background, the baby picture of the universe, now possibly just photobombed by ancient galaxies. The Webb telescope recently observed a whopping 30,000 galaxies. And guess what? Most of them are spinning in the same direction. That's right. Like the universe coordinated a giant cosmic dance recital, and nobody told us. This is very weird because, according to the classic Big Bang theory, the early universe was supposed to be a chaotic mess with galaxies spinning randomly like drunk figure skaters. But no, these galaxies are synchronized. They are spinning with a kind of order that has scientists raising both eyebrows and asking, did the universe start with a spin? Even more mind-blowing, the further back in time they looked, the more obvious this cosmic spin trend became. Galaxies from the early universe showed even more alignment. It's like the deeper we peer into the past, the more the universe starts acting like it had a plan all along. And that plan didn't involve randomness. Dr. Louis Chamet and his team dove into this galactic rotation mystery, and their measurements of redshift revealed a pattern that completely defies our current models. This isn't just quirky data. If true, it's revolutionary. It hints that something fundamentally different is going on, something our current theories can't explain. But we're not done yet. Just when scientists thought they'd seen it all, a study published in Physical Review D dropped a cosmic bombshell. What if the entire universe is actually inside a black hole? Yep, you heard that right. According to researchers at the University of Portsmouth, our universe might not have been born from an infinitely dense point in a fiery bang, but rather from the other side of a collapsing star, a black hole that bounced. Professor Enrique Gastiñaga, one of the minds behind this jaw-dropper, explains it like this. Gravity can crunch matter down to unimaginable densities, but it doesn't have to end in a singularity. Instead, that matter might rebound, launching a whole new expanding universe. And the cosmic edge? That would be the black hole's event horizon, a barrier beyond which we can't see, because it's literally the limit of space and time. So, what if the reason we can't observe what's outside our universe is because there isn't an outside? We're sealed in like raisins in a gravity-flavored pudding. From cosmic choreography to black hole birth certificates, one thing is clear. The Webb telescope isn't just showing us pretty space pictures. It's challenging everything we thought we knew. And if the universe is playing by rules we haven't even imagined yet, we've got a lot more cosmic homework to do. Now, here's a cosmic curveball that'll bend your brain like spaghetti in zero gravity, the black hole universe theory. According to this bold idea, the universe didn't pop out of nothingness like a magician's rabbit. Nope. It may actually be part of a grand ongoing cycle, a cosmic loop of death and rebirth where collapsing universes become the wombs for new ones. Think of it as a universe's version of reincarnation. Collapse, rebound, repeat forever. This idea isn't floating alone in space either. It actually echoes a concept from none other than Nobel Prize-winning physicist Sir Roger Penrose. He calls it conformal cyclic cosmology. For those of us who like our mind-blowing theories in snack-sized acronyms, according to Penrose, the Big Bang wasn't the once upon a time of everything. Instead, it was more like the opening scene of a new season in a never-ending cosmic series. Each universe, or eon, as he poetically puts it, ends not in fire and brimstone, but in a cold, stretched-out fade. And just as that one winds down, a new one silently kicks off. Yep. According to this view, we're living in just one chapter of an epic saga that may have had countless universes before ours, and who knows how many still to come. Maybe they even had better Wi-Fi. The Webb telescope is out there snapping deep space selfies, uncovering clues that could help us piece together the ultimate mystery. Not just how our universe began, but whether it ever really began at all. So grab your popcorn because this cosmic show is far from over. And with the Webb telescope continuing to peel back the veil of the universe, the next twist in the story could be even wilder. Einstein just got a cosmic curveball. And trust us, it's terrifying. If the Webb telescope's latest discovery has you saying, "Wait, what?" then you're in the right place. Hit subscribe before the universe unravels any further.